One of the things I am not is an engineer. As you'll find out very quickly from this talk, as well as from like the last time I committed anything to production, this is not the world that I live in. I am instead an analyst. I don't really know what it says about our profession that Jonah Hill has somehow come to represent analysts, but this is what I do. So my job is to take data and turn it into insight, help our business make decisions, those sorts of things. I am not someone who's off building machine learning models or building data platforms. I am sort of the person who applies things on top of that. Specifically, I work at a company called Mode. So what Mode does is we build one of those platforms. We build a tool for data scientists and data analysts. As a bit of reference, this is what it looks like. It's like got a web-based SQL editor. You can run queries, you can get results, you can pass those results to an embedded Python notebook, create dashboards, create reports, share those things out. It's very much designed for folks like me to be able to build reports and build reporting, build dashboards, do analysis for other folks around the business. And so one of the things that we discovered when we were building this is, one of the things that's really important for building tools for folks like me is the connotation of that product. It's important that the product doesn't just have the functionality that we want it to have, but it also speaks to the customers, that analysts are kind of a finicky bunch, and we want to be able to make sure we're serving those customers correctly. And so the things I want to go over today is kind of coming to y'all as the folks who are building the futures of data tools to say these are the favors that we as analysts are asking of you. These are the things that we care about in the tools that we have. So a big part of our job, again, is to build on top of the stuff that data engineers like y'all provide, and we want to make sure that we can do the things we want to do. And so the way that I want to do this is Stephen Colbert, back when he was the Colbert Report, had this whole thing about better knowing a district, make it about better knowing an analyst. So like, what is it that analysts are like? What is it that defines kind of how we think, the kinds of tools that we want, and not just, again, in sort of we want X, Y, and Z features, but what are the kind of requirements and the connotations of the products that we use that make the ones successful versus the ones that aren't. Before kind of getting into the weeds of this too much, one quick kind of bit of housekeeping. I'm going to use the words analyst and data scientist interchangeably. To some people that will be very offensive. I don't care. It's something that people don't have clear definitions for these things. I'm referring to folks who are using data to be able to find insights about their business. This isn't necessarily the folks who are off building machine learning models and those sorts of things. There's a lot of overlap and sort of blurry lines between these different kind of professions. But when I talk about this here, I'm mostly talking about the folks who are trying to find business insight and change the way businesses behave based on those insights. So to frame this entire conversation, I want to use this Maslow's hierarchy of needs for analysts. So this is a sort of a famous psychological construct about what we as humans need. So like, what is it that we as analysts need? What are the things that sort of move us up this pyramid as analysts? So to start us off, what's at the bottom of this? What do we need to do our jobs? So these are some of the things that, like these are these psychological needs, or physiological needs rather. These are some of the things that folks are probably familiar with, but I want to run through some of those pieces. And so if you were to kind of Google this and just say like, hey, what is it that an analyst or a data scientist is like? You kind of see this sort of Venn diagram a lot. Like this is something that gets passed around a good bit of like, this is what makes up a data scientist. They're people who know engineering and have engineering skills. They're people who have some business expertise, and there are people that are familiar with statistics. So these are kind of the basis of these physiological needs to some extent. One of those things is data engineering. So like how much of data engineering is actually on this base layer? For a lot of analysts, again, not necessarily for the folks who are building data engineering pipelines, but for a lot of the folks like me, data engineering it's like the engine of a car. It's something that we rely on, it's something we're counting on, but it's not necessarily something we spend a lot of time thinking about. We want it to work, but we don't actually want to get into the nuts and bolts of how it works a lot of times. We are consumers of that product, not necessarily people who are in the weeds of how it all works. So sort of no offense to data engineers, this is a Prius engine. I'm sure it's a much more powerful engine that most folks are building. So what other things are fitting on this? So SQL, there was already, the last talk had a lot of talk about SQL. SQL is a very foundational thing for most analysts. It's very hard to really do your job as an analyst without having SQL in two ways. One, it opens the door for the data that you're actually using. That as an analyst, most of the data you access lives behind something that speaks SQL or something that looks like SQL. This is typically the entry point for the work that we want to do. It also is kind of the entry point for much deeper tools. So for a lot of folks who come into analytics from other careers, from things like consulting or sort of MBA type roles, a lot of those folks are coming from Excel. SQL is kind of the gateway drug to more technical tools like Python and R and other things. So SQL is a very important thing for a lot of analysts. This is a much less insightful chart compared to the one from the last slide, but if you just like look at job listings for analysts and data scientists on Glassdoor, SQL is way more popular than these other things. As a result, we as analysts do kind of crazy stuff with it. If you see what we do, it's like, great, we use it for analysis or data mining or data science or machine learning. So like people try to do a lot of stuff with SQL that may not necessarily be obvious. Some people also do math with it. Another thing about SQL is that there's a lot of parts of it that we sort of don't necessarily know a lot about. Much like data engineering in general, we care about using it as a tool. We don't necessarily care about the inner workings of it. GroupBy is an interesting thing that obviously if you're familiar with SQL, it's something that's really important. Like you basically can't do any sort of analysis with it. Most analysts have no clue how it works. It's just a thing that you stick on the bottom that you know it has to be there. You know how to use it, but like what does it do? Why is it why do you have to do that? It's not really a question that we often ask. And so for a lot of analysts, this is the way that we apply our tools. We want to understand how they work to get the job done, but we're not digging that deeply into the inner workings of it. So you can see, like, if you ask, what does GroupBy do? You get these kind of tautological answers of like, you use it for aggregates. Like, what does that mean? I have no idea. Another thing that sort of is an output of data engineering that analysts care a ton about is user-friendly data. This is a thing that I think is fairly obvious, but often goes wrong when folks are building data for analysts, but don't necessarily have sort of the connotations of what those analysts are trying to do. So to show some examples of that, say you've got this table here of all these different things, and it kind of looks like, okay, this might be pretty good. But there's lots of things, like little things in this that go wrong that cause a lot of pain for analysts and can make analysts frustrated with the tool or pipeline or data that you're building. So for instance, there are these 3 timestamps. You may think, great, this is a much richer data set. It explains when this record was created as well as when the actual nightmare in this case started. These are 2 different things. It's important to have those timestamps. For analysts, we often just don't know what this means. We end up looking at this and we're like, I'm not sure which one to use. I'll use one, somebody else uses another. As a result, we get very different results, not sure why, just because these things aren't that clear. Another thing that happens sometimes, it's a kind of simple problem that you'd think, I'd never do that, but people do, is people will name columns things like timestamp, which in a lot of databases is a reserved word. And if you write select timestamp from my nightmare, you get an error because it'll be like, you can't use timestamp as a column name. Another thing folks will do is they'll put periods in column names. It ends up resulting in the same thing. This SQL query doesn't work either because you can't have periods in column names. So it's lots of these sort of little usability things that don't seem like big problems, but when you're an analyst writing a bunch of queries every day, these are the sorts of things that are immensely frustrating and hold you back from doing your job. Other things like this is repetitive dream or something. I don't even remember what this was when I wrote it, but that's the problem with it. People will have these column names that aren't well described. It's hard to figure out what it means. Again, as an analyst, you have a hard time actually consuming that data. And then finally, sometimes things are all named in all caps. As a result, you end up writing a bunch of queries like that. You spend a bunch of time staring at a text editor that has all these all caps, and then it just feels like everything you're doing is yelling at you. It's not a big deal. It's the sort of things that, like, small things that we will complain about, but it's the small things that drive us away from one tool into another one. So another thing on this sort of bottom layer of expertise or physiological needs is business expertise. So how much do we as analysts actually have business expertise about solving business problems? To again kind of go back to the previous slide, previous talk, MBAs are actually not very important at all. So if you think about like the formal definition of business expertise, for most analysts, it's not something that we have. We're not folks coming from a lot of places where we talk about the things that typical MBAs would talk about. Most analysts are coming from other backgrounds that don't necessarily have that kind of experience. There's a lot more PhDs, for instance, than MBAs in this field. Final thing on that kind of Venn diagram was statistics. How much is statistics actually play a role in our job? If you think about like sort of the stereotypical way that you think of a data analyst, it's people who are very interested in things like statistics. You end up with Quora questions like this, like I want to be an analyst, but I don't want to sit in front of a screen and do equations all day. Statistics is a little bit of an interesting thing for most folks who are analysts. I would compare it to the way that like algorithms are for engineers. You ask an engineer, like, do you write algorithms? Most people are like, no, that's not at all what an engineer does. Though there are a few folks who are very specialized in that field. There are a few folks who do actually write algorithms all day, in the same way that there are analysts that work in statistics all day and are like very deep in the theoretical side of statistics. Most of us are not. Most of us use it as just a tool to get the job done, a tool to answer questions, but we're not people who are like deeply aware of all the different things that you can do in it. So for instance, one example of that is if you're someone who focuses primarily on things like A/B testing and optimization, you're very deep in this world. You understand a lot of different things about different statistical models that you can apply to different A/B tests, different way to try to forecast when to end A/B tests, things like that. But for a lot of us, this isn't the world that we work in. We instead work in a world like this, where we're looking at this chart that's got active users for some business. People come to us and say like, hey, what's going on with this chart? Why are active users down? And the last thing we can say is like, well, don't worry about it, it's not statistically significant. Like, we can't apply statistics to, hey, the business is falling apart, and say, don't worry about it. Like, that's not really what the problem here is. The problem is we want to understand what's happening, and we want to be able to actually answer that question and explain, hey, this is the behavior we're seeing, not turn it into a theoretical or academic problem. So, to move on to the next level of this pyramid, what is it that stresses us out? Like, what are the things that cause, if those are the base things we need, what are the things that make analysts stressed? So that is this safety and security pyramid layer. One thing that may be obvious for folks is how fast stuff runs. So this is a place where we very much appreciate data engineers. The faster our queries go, the much happier we are. The slower we go, the much more stressed we get. Why is this? Because we write a ton of queries. So Mode, like I mentioned in the beginning, is a platform for analysts. We have a bunch of people running millions of queries through our platform every day. On average, an analyst writes 160 queries a day. So we're sitting around writing these things. It's a ton of queries. Those queries take, on average, about 20 seconds to run. If you do the basic math here, that means we're sitting around waiting for queries to run for about 53 minutes a day. So that's a lot of time to sit around and wait. It's a lot of time for us to either feel the pain of things moving really slow or to be excited when something finishes quickly. So that's one of those things where, as data engineers, as people thinking about the kinds of stuff that analysts care about or your customers care about, just being able to make things go fast makes a huge difference for us. Another way that we care a lot about is why data changes. So again, we're not necessarily like in the inner workings of what the pipelines look like, but if something comes out the other end that looks different than it did yesterday, that's the kind of thing that causes a lot of stress and causes us to go down a bunch of rabbit holes to figure out what happened. So for instance, say we come along and we like write select star from users today, and we've got these 2 users, and then we come along tomorrow and Gaston has been deleted and the beast is gone. It's very confusing as to what happened. And like, our results now have to change. We have to go back and say like, what happened to our analysis? Why is our results different? This is the sort of thing that sends analysts down a lot of rabbit holes and puts us in a place where we have to like rework problems that we've already solved. And so if there are ways, I actually don't know of a good way that people solve these sorts of problems for you to be able to understand like how is data changed and those sorts of things. But if there are ways to solve these problems, again, this saves us a ton of time and a ton of headache about like what's going on and the results that we've found. Another thing that analysts are often stressed about is things like Git and GitHub and sort of the fringe of the technical skills that we are supposed to have, but don't necessarily have as much as perhaps we should. So this is how a lot of analysts, and by a lot of analysts, people like me, use Git. We'll be like, cool, let's go commit something. We've done some analysis. We've sort of changed our basic model. We'll do this sort of stuff. We actually forgot to pull it, and then we're like, okay, git pull. No, try it again, do it again. I don't know, like that. Sudo git pull, I don't know. Still didn't work. All right, start all over. So like, this is kind of the experience that we have with some of these things. And don't even get me started on merge conflicts. I have no idea what you're supposed to do with a merge conflict. We can figure this out, but again, it's the kind of thing where this isn't really the domain of what analysts do. We know it's like the place to up-level ourselves, and that analytics is becoming more and more technical and more of an engineering field. But to the extent that we can be enabled by the tools to learn that and to be educated in that, that's something that can save us a lot of stress. Another place, again, that causes some anxiety is SQL. We use it all the time, but as a result, we find a lot of weird things that it does. So for instance, say you go back to having this table, and you write this query, like, great, that works. Now you get rid of the comma. Now it doesn't work because it shouldn't. Now let's replace that column with a column that doesn't exist. That works. Now you do this. You're like, I don't understand what any of these columns are. You run that. That works. So SQL does some weird stuff. If you want to like talk to people about weird, nerdy things about SQL, talk to your neighborhood analyst. So yeah, so this is a place, again, where SQL is a powerful tool, but there's some lack of clarity in it that would go a long way for us to be able to use it more effectively as well. Another thing that's a little bit more trivial that causes analysts a lot of stress, if you ever want to start a fight with a bunch of analysts, ask them how they format their SQL. Some people do this, that's okay. Some people do this, that's terrible. Sane people do this. Some people do it like all in one line. If people are like very passionate about the way they do this, we actually at Mode just released a feature that encouraged a particular type of formatting. It was very well received by some people and not at all well received by others. So yeah, this is a place where, again, we stress out about things that perhaps we shouldn't. On a little bit more of a serious note, a thing that also is a place that gives analysts trouble is answering what should be simple questions. So a good example of this is, you probably, if you're working for a business, you want to know, how much money do we make? It seems pretty basic. It seems important. It's just like add up the number of bills that people are paying you and you're done. In reality, typically being able to answer that question requires you to go through some chart like this of like, was it a trial? Did it get canceled? Well, was it a test account? Was it an account that only paid partially? What happens if the credit card got declined? All this data was entered by humans. What happens if it was entered wrong? These are the sorts of things that a lot of our work is done trying to solve, is answer these simple questions that end up being very complicated because of how the data is structured, because of how the business is structured, and the way that we can like abstract this away saves us a lot of headache as well. Our ability to be able to answer what is simple, or to be given data that sort of handles a lot of this for us, can make analysts much more effective in answering sort of the deeper level questions that we're more motivated to answer. Similarly, another thing that probably gives analysts more stress than anything is when a dashboard goes down. So again, returning to this chart, as soon as this happens, what happens is some executive will come to you and be like, what in the world happened? Why are we losing users? Figure it out. In some cases, it's easy to find the answer. It's like, oh, we shipped a bad app, that the sign-up flow is broken, that it's a holiday somewhere. In other cases, it's like trying to chase why the stock market went down. You have no idea. It's just a bunch of noise. If there are, again, places for us to be able to point to being able to do these sorts of like diving into these really hard problems that don't really have an answer, we spend a lot of time going down these rabbit holes to try to understand what is sometimes noise and what is sometimes not. One, as an aside, analysts often have, or at least ones that work in SaaS businesses that are B2B, a lot of knowledge of international holidays, because those dips are often caused by international holidays in like the Netherlands somewhere, and it takes you a while to figure that out. So for instance, at Mode, we have this reference of international holidays that we can check against anytime we see a dip like that. The last thing here that again gives us anxiety is change, and it's not just change in the data, but it's change in the structure of the data or change in the structure of the business. That we'll build analyses, we'll build sort of the way that we want to do things. This is how we do our reporting. This is the way we define revenue in that very complicated way. And then something about the business changes. Either the way that we sell changes, or the way that we report it changes, or we decided we want to report in a slightly different way. And this happens all the time. And so we want our tools to be flexible to this. As an example of this, so this is, again, Mode as being connected to a lot of people's data. We can see how often schemas change in people's database. And on average, they change about once every 5 hours. And so that's the level of change that analysts are having to work against. It's not a static model that we build everything on top of, and then once every quarter there's some big business change. These things are constantly evolving as new marketing campaigns go out, as new like sort of sales processes go out, as new products are shipped. And so we have to be constantly reacting to those changes. All right, so moving up again. So the third level in this pyramid is the belonging, the feeling of like social belonging. So how is we as analysts connect to other people? We're not always like the most social bunch. So how do we go about doing it? So one way is presenting our work. This is a huge thing that tools need to enable us to do. that analysts don't make charts and dashboards for the sake of making charts and dashboards. They do it to share it with other people. And so much of what we're trying to do, of all of these things, of like collecting data, storing data, manipulating it, modeling it, analyzing it, visualizing it, all of that is aimed at trying to communicate it and help other people understand it. And so much of the interaction that we have is through the work that we communicate. We have to work with folks a lot as well, but a lot of the things we're trying to do is distribute our work around the organization to the people who need to make decisions based on it. And so tools that don't enable this are tools that really constrain analysts to be more inward focusing rather than outward focusing, which just makes them effective as a business. Another thing that analysts will do to communicate a lot, and if you've ever talked to an analyst, you probably noticed this, they communicate a lot in analogies. There's actually, I think, a reason for this, that a lot of what analysis is sort of stripping out complexity from a problem, taking it down to like a skeleton and mapping that on to some other skeleton that you can more easily understand. This is basically what analogies are. And so a lot of times when analysts are talking to folks, they'll put together these sort of simple mental models of this is how the world works. This is how I would explain this problem. And so you see this all the time. There's actually this really nice Paul Krugman quote about this, that these sort of things are really powerful. I mean, I very much believe this, but I think this is something that deserves a lot of credit for people to be able to communicate in this sort of way, that being able to take something complicated, strip out the complexity again, and turn it into this really intuitive story goes a long way in explaining these complicated concepts. Another way that we, as analysts, often will work with other folks is by trying to understand the things that people are asking. That a lot of times analysts are seen as sort of a consulting agency within a company. They're seen as a service arm where people go to them with questions. They say, hey, can I get this data? Can you help me understand this problem? Can you help me understand some part of my business? When that happens, if you come along and say, hey, like, why are active users dipping? You may think, hey, the response here is like, here is bullet 1, bullet 2, bullet 3 for why. Typically, the answer you'll get from an analyst is like, why? The point of that isn't necessarily to push back. It's not to be difficult, but it's to try to understand, hey, there's lots of different ways to answer this question. How can we most effectively answer that question for the problem that you're trying to solve? The double-edged sword of this is there's a lot of like bedside manner in this that analysts also aren't very good at a lot of times, where it does seem confrontational and doesn't always seem like it's a productive asking why. It seems like it's more pushing back. This is something that like we'll work on. I don't have any clever slides for why in the world we're bad at this. Okay, so what about at the top of this pyramid? Like once we get above kind of the basics, this is what our job is. What is it that actually makes analysts feel successful? And this is, I think, what separates the successful tools or the successful teams from the ones that are sort of just doing the job. So that is this fourth esteem pyramid. So this is like what makes analysts analysts, is a lot of times people who are in data fields, if you go out and talk to somebody who's not at all in the space, they'll assume you do it because you want to work with data. You'll play fantasy football and they'll be like, great, it's the data guy. He's going to like crunch a bunch of numbers to draft his team. Analysts aren't really in this for the data alone. Most people are in it because they're interested in what the data tells them. The point isn't like, I love numbers. The point is, it's interesting to understand how the world works. And data is a really compelling way to figure that out. This book is one of the most popular books I know among people who do the things that I do. It's a book by Christian Rudder about how people interact with each other on OkCupid. It is not something filled with a bunch of complicated analyses. It's not something filled with like super technical content. It's something filled with a bunch of interesting questions about how people behave and some data that shows that this is the way they do it. So like that is ultimately a lot of the things that's driving analysts to be what they are, is to just answer these questions about how the world works. So some examples of the sorts of things that I think people on our team at Mode have been really interested in, just like lunch table kind of conversations that makes analysts sort of excited and fired up. Is like, I wonder whether or not weather affects election turnout, which it turns out it only does in non-competitive elections. People wondering, I wonder what happens if icing the kicker works. It mostly doesn't, though that's kind of disputed. People wondering if younger founders are more successful in tech companies. It turns out they are not. And people wondering if West Virginia is in the South. And it turns out it is, most people think so, unless you're from West Virginia, and then nobody thinks so. So these are the sorts of things that really motivate analysts. Again, it's not like I want to go play with numbers, it's that I want to answer these kind of interesting questions about how the world works and have a better understanding of sort of my environment, my company, or just kind of the world at large because of it. Part of that, and part of what that extends into, is analysts are also very interested in caveats and nuance. This can be a frustrating thing if you're engaging with one, because they won't necessarily say things in strict terms. There's a lot of suggests and indicates and points to. But the reason people do that is because analysts, again, want to be able to explain the world. And describing the world is often a complicated thing. It's not always a clean story. It's something that has complexity, it has uncertainty. And so, like, if people were following along with the election coverage, 538 publishes this like fairly complicated chart for this was their prediction right before the election about where things would settle in the House. People, if you sort of looked at their Twitter comments, which is probably a dangerous place to be, people are complaining like, just say what's the number? How many seats are they going to win? What is your forecast? Why can't you just like stand on a forecast and say that's it? And that's not a representation of the way the world works. That analysts want to introduce this complexity and this kind of uncertainty in it because they're trying to more accurately portray the world. And so when we communicate work, again, either publicly or in a business setting, we want to try to do it in this sort of way. We want to try to represent it accurately rather than just saying, hey, this is going to work or there definitely isn't going to work. So then, what's at the very top? What is it ultimately that sort of fulfills us as analysts? If this is the stuff that makes us successful, and these are the things we want to do, what are the things that like give us a nerdy analyst high when we can actually do them? And so a big one is understanding why. It's not just about understanding the world, but it's understanding why the world behaves the way it does. And if you think about like what data is and kind of even where like statistics came from, a lot of this was around the framework that data tells an objective truth. That the way the world works can be described in data, that's all you need, and that's the providence of machines. For analysts, we don't necessarily see it that way. That understanding causality and causal inference is something that isn't just in the world of machines. It requires something that's much more creative. It requires a much sort of higher level of thinking that goes into understanding relationships in the world that aren't obvious in data and understanding what counterfactuals might be out there and having the imagination and creativity to explore these problems and think about what would the data look like if these things were true. These aren't things that you can necessarily plug into even the most complicated like machine learning models or neural networks and get answers to. They are things that require what is at this point only human reasoning. And being able to answer those questions is the sort of thing that analysts are really driving towards, like understanding not just what does this data say and what are these relationships, but why is the world behaving that way? If people are interested in this, there's this really interesting book. So this is a causal diagram. Judea Pearl is kind of one of the foremost thinkers in this. He recently had a book called The Book of Why, which gets into like why this kind of causal thinking is something that is still well beyond what machines and data science can do. And he was the person who first developed neural networks, so he's not coming from it from a perspective of like hating on the technology. It's just that technology doesn't yet replace what this like why question is that analysts so desperately want to answer. The second piece of this, I think, that is one of the most important parts of an analyst job, and one of the ones that, again, is kind of at the top of this pyramid, is telling a story about what this data says. That as analysts, we don't see our job as to ship off data to other folks and say, hey, here you go figure out what this means. Here's a dashboard, here's a report, here's some insight, and now you go figure out like where to take it. A big part of the reason we do what we do is to try to drive behavior and help people understand and change the things they do because of that. That analysis isn't just a handoff, it's part of a storytelling process to be able to say, this is the way the world works, this is how we interpret it, this is how we think things should change, and then we want to follow through on that to see if we were right. And so I think one of the ways you see this is if you look at the people who aren't necessarily the best data scientists in the world, but are some of the best storytellers in the world, this is how they do it. So if you look at the types of graphics and data visualizations the New York Times does, even though the visualizations themselves are incredible and can very much stand on their own, they never do. The New York Times always just tries to say, let's put story with it. Let's put a narrative to this. Let's tell people what they're looking at, help them understand it, and guide them to how to explore it on their own, rather than just present these really rich visualizations by themselves. And if the visualizations the New York Times creates, which are way better than anything people would create in companies, aren't good enough to stand on their own, then the types of dashboards that we as analysts would build rarely would be able to as well. So what does that mean? What do we want from like data engineers? What do we want in our tools? What are the things that we're really after as analysts in kind of this ecosystem? Basically, this, like, going back to this pyramid, the things at the bottoms are the things that sort of like are the table stakes. They're the things that make us choose a tool or not choose a tool because we have to. They're the things that will, like, if we can't do SQL, for instance, in a lot of cases, it's like, well, that's a blocker for us because we have to get access to data. But really the things that drive us to choose something versus not is how well does it affect us on these top layers. It's the things that help us actually do the things that make us feel proud of what our job is and answer the questions that we're sort of intrinsically motivated to answer, rather than the ones that just like do the job and that's it. So to make that a little bit more concrete, what does that mean? It means as analysts, we want to use technology. We don't want to be prescribed it. We don't want to be told we have to use this or this. We want to use whatever technology is most flexible for the challenge we're trying to answer. It also means that data should be created for humans, not machines. We are the consumers of this data, that we are the customers of a lot of like data engineers in product. And we want to feel like those customers. We want to be able to take that data and understand this is for us and this is for people to interact with, not strictly for machines to interact with. We want to express complexity. We want tools that enable us to show how complicated the world is and be able to communicate that complexity rather than having to hide it and rather than having to just say the answer is yes, the answer is no, the answer is higher, the answer is lower. We want to be flexible to change and not something that's undone by it. So tools that are rigid, tools that don't like respond to a very quickly changing world, tools that don't respond to changing data infrastructures, tools that don't respond to changing businesses are tools that, again, are very challenging and can be frustrating. We want tools that can lean into that kind of change rather than tools that are making assumptions that that's not going to happen. And finally, we want tools that can help us share the stories of what data tells and the why behind it, not just a tool that lets us say this is what the data says. That again, so much of what our job is and what motivates us to be analysts and to work on these sorts of problems is being able to tell why and being able to be a part of that storytelling process rather than just people who are curating dashboards or curating numbers for other people to consume or interpret on their own. The last bit of this to close on an analogy, because that's what we do. The way that I've always thought of this is that ultimately as analysts, the tools that we want are tools like radio towers. There are things that we want to be able to put up when we have a question and want to be able to get somewhere. We want to be able to build it very quickly and very tall very quickly. We want to be able to explore problems of like great depth very, very quickly. We don't want to have to build this kind of slow building monument that we slowly build up to hard questions. We want to be able to go from the ground to a very hard question and answer very quickly. And then if we find an answer, we find something interesting there, we can go figure out where that takes us and build another radio tower on top of that question. Rather than, again, having to go and kind of build something up from the bottom very slowly, we want to be able to do these very quick explorations, figure out what's interesting, figure out what's going on in the world, figure out why, and then be able to communicate it. And I hadn't honestly even thought of this part of the analogy until just now, but we're going to be able to broadcast it out much like you could in a radio tower. So that is what I've got. Questions?
You're probably familiar with DBT.
Correct.
Their philosophy is that analysts should be doing sort of software development lifecycle things like Git. Do you agree with that? Do you think that that's into like what the analysts should do?
Yes. So I think that analysts need to be better at technical skills. That Git example is something that like analysts need to be able to overcome. And I very much agree with DBT's philosophy that like especially the sort of final mile of data pipelines are better off left to analysts who are the ones actually consuming that data. That much to the point, the second one, that analysts are the ones who are the customers of that data to the extent that they can also be the creators of it, it enables them to be much more effective. So yeah, I think like the Git piece isn't necessarily saying, hey, we shouldn't have to learn that. It's more, we should, but how can we help, like how can tools help us get there rather than just saying, hey, go learn this thing. The other side of that, the one place where I would sort of take a slight disagreement with some of the things that I think the way the DBT expresses this, is I don't believe analytics is like a subset of software engineering. That the problems that analysts solve and a lot of these other things on this slide require a very different way of thinking than the way that engineers think. It's just a different kind of problem. That what makes a great analyst is their ability to be creative in the way they think about like asking questions of data, the ability to like ask counterfactuals and those sorts of things. I think a lot of those skills also apply to software engineering, but it's not necessarily the same thing. It's sort of a sister profession rather than one that is sort of a subset.
say that analysts need tools to share stories that tell why and not only what. Do you have a good example of the type of tools that are used?
I mean, I'm biased. I think Mode does a decent job of it. But part of that is just giving you the, so as a very simple case, one of the things that Mode does, so Python notebooks are a good example of this too. One of the things that Mode does that notebooks do, and you can also do in something like R Markdown, is it gives you the ability to add like narration. It gives you the ability not just to present a dashboard and then leave kind of the interpretation up to the person who's consuming it. It gives you the ability to point something out and say, hey, I looked at this chart and it told me that something was going on here. So I investigated this. Turns out it wasn't that. I then investigated this and it turns out like there's some leads in that. So part of it is just not expecting people to have to come up with that all on their own from just looking at a chart. It's being able to like describe those stories as they consume it. So again, I think that's why like the New York Times is a good example, that they never leave it up to you entirely. They let you explore it if you want and say you can go deep, but we're not going to like make you figure out what you're supposed to come away from this. Yes?
Do you know if this is on?
I have no idea. Sounds like it.
All right. So a bit of a comment and then a question.
Sure.
So we've actually taken that the answer to simple question, which I think is really important, we've sort of flipped it on its head. So the system that we've built, one of the goals is to actually pre-answer all of those simple questions and put them in front of the people who actually should know what those answers are. And so really what you end up with is this sort of checksum where you've cut the data across many dimensions and then integrated it up and put a number in front of somebody who has a pretty good idea of what that is, and it's a way of sort of building confidence and faith in the underlying system. So we've actually had a lot of success with that, and we find it's a really good high-level way of figuring out if anything has become inconsistent in a way that, as a data engineer, full disclosure data engineer, that we might not actually know. Do you have any suggestions from the analyst side of things like that that can help data engineers sort of build faith and trust in the systems that they're building and that the data has integrity?
The things that data engineers can use to sort of check the integrity of their data?
Well, to help the analysts feel confident that what they're using is sound.
Yeah.
You mentioned going back day to day and that the data is changed. Sometimes it's mutable and that's necessary.
Yeah.
Sometimes it's not and it does.
So yeah, so I think an example of this where we've seen this come up, not necessarily with consumption from analysts, but from other people in a business, and this sort of trickles down to analysts, is businesses will start on Google Analytics. You're a 5-person company, you're like, we want to see how many people are looking at our website, let's use Google Analytics, we have a number, we get 5,000 people a day. We then say we want to migrate to something else. It's time to move on to a tool that can do a lot more. And they'll then migrate to some other platform, they'll now say, we get 4,800 people a day. There's lots of reasons for that difference. That the way Google computes sessions might be different. It might be counting something slightly differently, like tracking is a little bit different. How do they do anonymous sessions might be different. But for people who are consuming that data, looking at that as like, oh my God, this was one number, now it's another. Unless people have good answers as to why these things are going to change, I'm never going to have faith in the second number. That no, there's some logical fallacies in that of like, why would you assume the first one is right? Like you just do, but being able to explain, hey, this is going to be different, or helping anticipate those things, at least from an analyst perspective to our customers, is by far the most important thing you can do when stuff starts to shift. Is like, yeah, like we're on top of it, not like, oh God, you're right, that is different. Let me go dig into that. So that I think is one thing. Another thing is kind of similar to what you mentioned, and DBT does a good job of this, of being able to provide what amount to like unit tests for data, to be able to just periodically run checks of like, are we recording events that don't match our schema? Are we recording, like, are there places where the purchase price of this thing was negative $10 and that doesn't make any sense? Those sorts of things that just be able to like find anomalies that are sort of invalid data, not anomalies in the sense of a spike, but anomalies in the sense of like this shouldn't exist, and being able to alert people to that provides a lot of confidence as well.